Hi everyone, today we will be designing and stimulating a simple NAND gate using System Verilog. Now for those unfamiliar, a NAND gate is one of the most basic digital logic gates. It takes two inputs and produces an output that's the inverse of an AND gate. So the output will be 1 unless both inputs are 1, in which case the output will be 0. We are going to use EDA Playground for this simulation. EDA Playground is an online platform that allows us to write and stimulate hardware description language code like System Verilog. We will be selecting Icarus Verilog as our stimulation tool and open EP to view the output waveform. I will walk you through both the design code and the test bench, explaining each step in detail. So then coming to the code part, first we will be going to the test code explanation. Alright, let's start with the design code for the NAND gate. We have a simple model named NAND gate. As you can see, this model has two inputs A and B and the one output Y. We are using the logic data type which is used in System Verilog to represent binary signals. Now the main part of this code is the assign statement. This is where we define the NAND operation. I am saying Y is equal to tilde symbol of bracket A and B, which means that the output Y is the negation of the AND operation between A and B. This effectively creates a NAND gate as it performs an AND operation first and then negates the results. Then coming to the test bench is used to test our design by providing various input combinations and observing the output. So here what's happening in the test bench? First we declare two logic variables A and B as inputs and Y as the output, just like we did in the design code. Next we instantiate the NAND gate by calling it UUT, which stands for unit under test. This connects our dispense signals A, B and Y to the inputs and outputs of the NAND gate. Now in the initial block, we set up the waveform dump using $dump file and $dump waves. What this does, it generates a BCD file which stands for value change dump. This file will record the changes in A, B and Y during the stimulation, allowing us to view the waveform later. After that, we initialize different combinations of inputs for the NAND gate. The inputs A and B will be set to various values, and after each change, we wait for 10 times units using hashtag 10. First, we set A is equal to 0 and B is equal to 0. Then we set A is equal to 0 and B is equal to 1. Next, A is equal to 1 and B is equal to 0. And finally, both A and B are set to 1. For each combination, the test bench will monitor the output Y to ensure that the NAND gate is functioning correctly. Finally, after testing all the input combinations, we call $finish to stop the stimulation. Then coming to the running of simulation in EDA Playground, now let's run the simulation. To do this, we need to select Icarus Verilog as our stimulator. This is an open source Verilog stimulator that's widely used for small projects like this. We will also select Open EP Wave as our waveform viewer. This tool will allow us to see how the output changes based on the inputs over time. Then coming to the interpreting the results, let's take a look at the waveforms. What you will notice is that when both inputs A and B are 0, the output Y is 1. Similarly, when one of the input is 1 and the other is 0, the output is still 1. But when both inputs are 1, the output becomes 0. This is the expected behavior of a NAND gate where the output is only 0 when both inputs are 1. Then coming to the conclusion, so to wrap things up, we have successfully designed and stimulated a simple NAND gate using System Verilog. We walked through the design code wherever we define the NAND operations and then use the dispense to verify its behavior under all input combinations. We also used EDA Playground to run the simulation and visualize the output waveforms. This was a simple and yet effective demonstration of how digital logic gates can be designed and tested using a hardware description language like System Verilog. Thanks for watching and I hope this gives clear understanding of how to work with NAND gates in System Verilog. Thank you.